Hello class, and welcome to Chapter 5. Chapter 5 is all about functions. So this is going to be, I don't want to say the video is going to be short, but as you can see, we have less topics to talk about. Functions are very, very important in any programming language, and so they do deserve due coverage. A function is a construct that is callable, that we transfer control to, that performs, it can accept input, it performs some computations inside of the function, and actually even that's optional. You can have a function that does nothing, though it doesn't make much sense, and it will provide a return value to us. Functions must provide a return value even if it's void, which means basically no return value. You still have to say, it's not returning anything. You have to kind of specify that. So you can, kind of think of it this way. Functions optionally accept input. They do stuff inside, which I guess, you can consider that optional too. And then they'll return you something, even if it's nothing. It's kind of a funny way to say it, but really that's how it is with the void return type, which we'll talk about. Main is a function. We've talked about this before. This is a special, this is kind of a special case of a function. And, excuse me. So the int we know is the return type. As I said, this, when we call a program, we call the main, whether we realize it or not. That's the, the main entry point into a program. And we can optionally pass things to the program, but here, in main, we don't. Here in this, example, we don't have anything we're passing, but we can optionally pass things into main, and then we return a value from main. Implicitly, it's 0. If you don't provide any return value, it will return 0 to you, meaning everything's fine. You can code your own error messages. Anything non-zero is an error condition, and you can kind of define your own error conditions. You could say, error code 2 for file not found, error code 3 for null value, I don't know, whatever, if you wanted. All right, and so a call, the anatomy of a call looks kind of like this. We'll just say we'll add two numbers, right? We'll have a function add to nums, int a, int b, and it returns an integer, right? If you think about it, we're creating the function accept two ints. We'll call them, they're called a and b in this scope, and it returns an int. And we return like so. Return keyword followed by the expression we want to return, the value we want to return. The value can be an expression. So how we would call this, and we've seen this, I think we've already called functions before. So we got a good priming. We'll just talk more in depth today. We'll take in two values, enter two ints. And then we'll take them in from the console. Actually, we want to have pretty display this time. There we go. There we go. So that's how we call it, right? What we do is we just basically put the function name here, and then in the parentheses we put the the arguments that we're passing. You see the parameters up here, a and b. Basically, first and second are the integers that we're passing to the function. We have to let the function know, hey, you're going to be receiving two integers, and first and second can be thought of as, basically we're passing the values of these two, and basically it re-aliases them and say, hey, your new handles are a and b for the purposes of this function. Everything inside this function references those two by the names a and b. And that's it. So let's try it. We'll just make sure this works. Very simple example, but hey, it's enough to get the point. And it does not confuse because it's quite simple. 1 and 8 will equal 9. There we go. All right, method signature. So this right here is the signature, the return type, plus the name, plus the parameter types are called the method signature. This is the method signature. Return type, function name, and the type and number and order of the parameters. That is your method signature. You can only have one method with the same signature in the same program. Watch what happens if I try to redefine it. I'll say, oh, I want to do the same thing. I'll just kind of like call these B and A. Oh, let's call these B and A or something. Redefinition. Yeah. No, it's saying no, dummy. You already have, it doesn't matter what you call these things. You already have a function that returns returns the same data type, has the same name, and has the same parameters and the same data types, right? Same data types. Doesn't matter what you call them. Now, overloading. Overloading is the case where we can have more than one function with the same name. Let's rename this thing, add nums, and then you'll see what I'm getting at. Voila. Now, if I just redefine this guy's A plus B plus C, then we're in business. Should be anyways. Watch it make me a liar or something. You never know if you did something silly, right? I am not above it at all. I'm sure you all will be much smarter than me. Oh, wait, added they are, blah, blah, blah. All right, so third was not declared in the scope. Well, yeah, dummy, you didn't put third here. All right, so you see what I do is I declare first, second, third, prompt the user to enter first, second, and then I add them together and return the result on the screen. Then I say, hey, enter 3. I just kind of, I reuse the same variables. We just kind of update the values in that location, memory location pointed to by these two handles, first and second. And then I read into this new uninitialized variable third. And then I add the 3 together and display them to the console. This should compile. Add 2 nums was not declared in the scope. Oh, yes, duh. Told you guys were smarter than me. I bet you were screaming at me when I did that. You probably saw the mistake I made. All right, so here we go. And add 2 ints. 7, 8 is 15. So, we could fix that like so. And, I'll add 7, 8, 9, which should be what? 24. 15 plus 9 is going to be 24. There we go. So these are... This is an overloaded function. We have 2 different signatures, method signature or function signature. All right, example of functions calling functions. Functions can call functions, and you can do this kind of an infinite number of times. You can eventually maybe overflow the stack, which is a certain area of memory which holds these, what we call stack frames, which we're not going to talk about at this time. So you theoretically could call functions iteratively forever, but you'll eventually run out of memory. You'll overflow the stack. But that's kind of, don't worry about that right now. You're not gonna get into any sort of program that complex, but you will see some stack overflow stuff out there when you become software developers. I have faith in you. You'll be great software developers. So check this. Let's redefine. Hey, here we go. Let's say for I don't want to do that. Okay, I got it. Here's what we'll do. We'll define a whole new function. I hate to do this because, I really hate for you guys to sit there with your eyes glazing over after 30 minutes of listening to me, but no biggie. We will make this one easy. So we'll say we'll make a function that calculates the area of, let's say, a square. No, actually, hold on. Let me get a better. I'll put myself on pause. Think of a better example here. I didn't. Sorry, I didn't really plan this one here well for functions calling functions. I kind of come up with a more practical example for you. I can come up with some contrived stuff, but let me think of something practical just a sec. Here, you know what? here's what we'll do. Aha! Got it. Okay. So we'll... Here, how about this? Here's an example. And these are just separate pieces done by functions. What we'll do is we'll say, give me a Fahrenheit value, and I'll go ahead and convert it to Celsius. I think we've done this before, but we did it in a single function. Here we'll do functions calling functions. Give me a val in Fahrenheit, and I will give you the Celsius equivalent. Yeah, temperature in Fahrenheit. All right, so we're going to take temperature Fahrenheit. We're going to read it in from the console. So now, so Fahrenheit times 1.8 plus 32 is, oh, sorry, Celsius times 1.8 plus 32 is going to be your Fahrenheit value. So therefore, you know what? Actually, here we'll do it the other way around. Celsius, since that's easier. I don't want us to have to strain our brains too hard. There we go. So we'll give a value in Celsius. We'll convert to Fahrenheit. We multiply by 1.8 plus 32. And that kind of gives us our landmarks, like, 10 is 50. I know that 30 is 84. 40 is 106. No. 40, yeah, 40 is 106 and so forth. Or no, 40 is 104. Sorry about that. And so forth. So what I'll do is I'll just call a function. So I'll say the value in Celsius is calc F2C. And I'll pass it our Celsius value. So that means I have to create a function called calc F2C, and I'll have to take, it's an int there, int temp C. Now I have to do something with this. I have to multiply by 1.8 and then add 32. So I'll just do the multiplication part here. So I'll say, no, here we go. Return, and I'll say, mult 1.8. I provided this value that we passed in. So I'll have a function that multiplies the value passed in by 1.8 and then plus 32. So then that would mean, if I try to compile this now, it'll say, hey, dummy, what is mult 1.8? I don't know. So here's what I'll do. I'll define this function. It's an integer. Remember, I passed an int in. And I'll say, hey, return 1.8 times temp C. All right. And so here, 1.8 is a double, or it's a floating point, so it will promote this value, this integer value, to a double when it multiplies it, or to a floating point value when it multiplies it by a floating point value. So then I have a floating point plus 32. And again, that's, one operand is float, so it will promote this data type to float, so returning a double is correct. So here, you see I've done this kind of piecewise, so I've had a function. So look at this, we use three functions. Main is a function, remember. Main calls calc F2C, which calls mult 1.8, so we're kind of three stacks in, if you will, if you want to look at it that way. Three function calls in right here. So I'll say, and this should make sense to us, in calc F2C. And here I'll say in, excuse me, in mult 1.8. All right. Oh man, temp F. Where did I say temp F? Temp C. All right, here, line 32, I'll bite. Oh, yeah. There we go. Give me a value in Celsius, I'll convert to Fahrenheit equivalent. Like I said, what 10 is 50. I know that. There we go. And so you see kind of the frame order, if you will, the stack order, the order of the calls. So give me a val, so we know we're in main, and then I call calc F to C. It shouldn't be surprised that next we see in calc F to C. And then it shouldn't be a surprise, since we transfer control to molt18 right here, that we see in molt18. Then at the return statement, we come back here and hit my return statement, and then I come back down here. And then we start again at line 33 and execute line 34, which is blank. So we just end the program. So that's an example of functions calling functions. You can do this, as I said, theoretically ad infinitum, practically no. So yeah, having more than one function allows us to kind of keep all relevant code in the same place. If we just have a big monolithic, main function, then that's going to be a nightmare. We don't have separation. We don't know. One of the things as a software engineer, as an engineer, you'll know your code bases more or less, right? You don't know every line in there. Right? Not even the pocket protector guys don't. You don't know every line in there, but you'll know kind of more or less where to look for stuff. You'll know where stuff happens. You'll know maybe what class, or at least in what module, kind of in what branch things lie. If we have one big monstrous main that spans 90,000 lines, that's going to be a nightmare of spaghetti code that we can't really. We'd have to use some weird control structures, and it would just turn into spaghetti code. Not maintainable. So this way you can kind of group your code together for maintenance, for troubleshooting, for debugging. Otherwise, you're not going to be a real software engineer if you just kind of have monolithic monstrous functions. A stub is, and as mentioned in the book, a stub is just if I know there's something maybe I want to do, if I want to have, so I have calculate Fahrenheit to Celsius. So maybe I'll want one here. I know, so I want one to calculate Celsius to Fahrenheit, and I know I'm gonna, accept, let's say, and actually this is wrong. We're calculating. I hope you guys got that. Like I said, you're probably smarter than me. There we go. So hopefully, we'll have one in the future. Let's say we want one named Fahrenheit to Celsius, and we'll accept a Fahrenheit argument. We could put that up here. We don't have to actually, code the body. So we just have what we call a declaration, which we'll talk about in a minute, but it's just there. We don't have to implement it. It's like a to-do, if you will. I don't know if you've ever seen those codes, to-do. The book calls it something else. I can't remember off the top of my head, but it's basically a to-do. It's something you'll fill in at a later time. Or you could just have it, kind of return maybe a dummy value or something simple for testing, or some known value for your test cases. But that's what a stub is. It's basically a function that's not fully implemented. Yeah, and this is a huge advantage of functions. Imagine if I just had this big monolithic main, and every time I wanted or needed to do something over the course of the program, I just had to write the logic instead of having it in a separate neat function that I could call multiple times. Imagine me trying to code the same logic multiple times. I'm human. I'm going to introduce errors. I'm not going to do it the same way each time. Even if I Control-C, Control-V, if I copy-paste, I'm going to make errors. So once you thoroughly debug and test a function, and you're fairly sure that it's, as error-free as you can ascertain, then there's a big advantage. There's a lot of value in just recalling it instead of trying to code, kind of trying to, reinvent the wheel there. So that's an example of reuse. That's great, and that's why, that's one of the big advantages of object-oriented programming as well. Reuse. Border cases. What you do when you test functions, you put different values in, or when you test programs, you'll put different values in, and you can do unit testing on functions. You'll want a variety of cases. Here, for example, in calculate Celsius to Fahrenheit, maybe I want a negative value, and maybe I'll want, ooh, look at this. If I have -1.8 I don't know, let's say minus 1.8, that'll give me a 0 there. I wonder how that'll behave. Where else is maybe a border? Oh, here we go. How about when the whole thing equals 0? Maybe I could test that whole transition point. That would be, you know, if I'm talking about if I'm pushing in a Celsius value, then you know what, negative 32 times C times 1.8 equals negative, hold on, negative 32 times 1.8 plus 32, so negative 32 divided by 1.8. There's a good boundary value where the whole thing equals 0. And I also want something to the left of it, just to the left of it and just to the right of it on the number line. That way I can kind of catch, you know, these corner cases as well. And then maybe I want a really big value. I don't know, 100 plus, something like that. So you want varieties in your test cases. You'll want them on boundaries of important things. Especially if there's logic involved that looks for kind of a, you know, kind of switches logic at a boundary. And you also want a little bit to the left and to the right of that boundary so that you can, you know, hopefully assure that all of your cases fall in some sort of, you know, branch condition there. And so here's something else to think about. Let's say, I want to add 10 to this temp value and then give the Fahrenheit equivalent. So what I'll do, I'll say, okay, here, you know, what, temp C is the same as saying temp C equals temp C plus 10. It's just a shortcut addition operator. Okay, we'll calculate the value of that, so then it should be, I don't know, you know, I think I gave it 10 earlier, so now if I give it 20, it'll be times what, 1.8 plus 32, which is 36 plus 32, which is 68. Oh wait, that can't be right, hold on, 20 times 1.8 plus 30, yeah, that's right. And so what I'll do, I'll say, hey, since I'm adding 10 to temp C in here, my temp C, if I input 10, then when I display it later, I should get 20 out, right? Let's see. Oops, darn. So anyways, we've got 68, but as you see, we get 10 back. Why did we get 10 back instead of 20? Because we clearly added 10 to temp C here. And it clearly calculates the Fahrenheit value from 20 Celsius. What happened? Well, here's what happened. We passed temp C in. So temp C is a variable. It's a location in memory that has a value in that location pointed to by this handle, temp C, which the compiler manages all that. Thank God we don't have to manage that again. But once I catch it here in the function, and you know, you can just forget the fact that it's called temp C. I could rename it anything that I want, as we see, because it's not the same variable. It is a copy of that variable. It is a copy of the, it's a value. Here we go. Let's put it this way. It is the value of this temp C variable passed into a newly created variable that is only visible in this scope. All right, so what happens when we pass like this? We say, we grab the value of temp C, which it was 10 in our case, and then we say, hey, in this function, I need a variable, we'll call it TC, fine, it's named TC, that initially has this value 10 from temp C in it. So this is a different variable that points to a different memory location. So when we mess with it, it doesn't change temp C. That's why you're seeing what you're seeing, pass by value. Pass by value is the default for primitives, you know, ints, doubles, floats, etc. Now, if we wanted this thing to change, it's really, really easy. Done. When you pass when you specify the ampersand after the data type, that means that it is a reference variable. So now what this says, it says, okay, I want to create a new variable named TC in the memory location pointed to by TC. Instead of just holding a value, I will hold the address of this temp C value, and then I will dereference that value, or dereference that address. In other words, I will get the value from temp C to obtain it, and conversely also, when I change TC, temp C will change. Now let's see what we get. We should get, output input 10, we should get 68 and then 20. Since we're adding, inside this function, we're adding 10 to 10. There we go. All right, so if you want to pass by reference, just use the ampersand. It's that easy. You know, you get into pointers, and we'll get into fancy stuff. Well, we won't in this class, but you'll get into fancy stuff with referencing, dereferencing, with the asterisk, and with the ampersand. Just know that the ampersand means a reference variable. It's tied, intimately tied, linked to temp C at this point, this TC variable. It is a separate variable, but they both point to the same place, if you will. All right. Pass by ref var. Oh yeah, so yeah, also I can we're here, int temp C, and I'll create new, here just for this one, I'll create variables ref1, ref2. You know what, here, I'll create a variable called, this will make it clear, myvar, and I'll create a variable called vyvar_ref. So as you can guess, my variable will just kind of be a plain variable. And I'll declare another variable, myvar, oops, no, darn, I don't need to declare any. I'll initialize myvar_ref with the same value as myvar. And what do you think we got if I do this? Here, let me be polite here so we can see it nicely. All right, so what do you think we got? 5 and 5, right? Let us see. Here, let me just get rid of all this stuff. We can leave these functions up there. They don't do anything. They're not hurting us. There we go. All right, so yeah, 5 and 5. Now, what happens, myvar? I'll add 5 to myvar. What do you think we have now? Do we have 10 and 5, or do we have 10 and 10? Think about it. Pause me if you want, and let's go. 10 and 5, why is that? Well, it's just an assignment here. We say, hey, what's the value of myvar? 5. Okay, so now myvar_ref is 5. That's simple. It's not dynamic. It's static. It's just going to give me the value at that time. Now, if you can guess, I bet you can guess what's going to happen now, since this is a reference variable. Oh. Hold on. Declared as reference, but not initialized. Oh, okay. Yeah. Duh. There we go. All right, so initially myvar has 5, then we say, hey, myvar_ref is myvar, but we do it in a reference fashion. And then we add 5 to myvar. So what do you think we get now? You already know, don't you? Yeah, there we go. So it's a reference variable. It points to my variable. So in order to get the value, it dereferences myvar and says, what's in myvar? Give me that. Global variables, outside function, yeah. So that is where we put global variables. A global variable is defined to be, anything outside of any function. Let's say You know, a good example, yeah, global variables, constants are great global variables. And I don't know the rest. I'm not a pocket protector type. But there's your global variable. So you can use it anywhere. You can use it, you know, inside any function. Its scope is just global, right? Its scope is everywhere. So you can reference it everywhere. I'm sure you guys will be much better typers than me too. Never really. I'm always a klutz on the keyboard, especially if I'm looking at what I'm typing. If I'm not looking at the screen, I can blaze, but if I'm looking at it, I don't know, for some reason, I just can't type quickly. Yeah, there you go. Pi equals 3. What did I declare? Oh, another silly mistake. And so there you go. So yeah, if you declare, you know, global, it's visible anywhere. Duh, name is global, right? Not local. You know, the scope, of course, is anything in the same block is going to have the same scope. Actually, that's not really true. If you have nested blocks, you know, as we saw, if you have nested blocks, then, you know, your scope, you can view everything outside of the block, but not everything outside of the block can view you, right? You go from the inside out. Yes. Watch what happens here. Let's say we'll go back to our example. Give me 2 numbers and I'll add them. All right, and so we'll declare a function that says, we'll implement a function here that add nums. So everything should be good in the world, right? I just return, you know, the first one plus the second one, and cool. All right, so we're reading from the top down, much like in English. The parser, you know, will read from the left to right, top to bottom. When it gets here, it says, dude, I don't know what add nums is. You're crazy. So we have 2 choices. We can put add nums above. Then it will compile because it knows what add nums is, right? That's it. Oh, first and sec, not second. So sort of like, you know, in math homework, if you, I don't know, you know, if you try to start at integration and it's referencing different, you know, differentiate, if your calculus, you know, if it's referencing differential calculus and you haven't, you know, even looked at differentiation yet, you're going to say, what is this? Same thing here. So you either have to declare it first if you want to use it, or I can let it know that somewhere in here there is a function. Let's say it first and second. That there is a function named addNums that takes an int and returns 2 ints. That way it says, okay, cool, it exists, no worries. That is called a function declaration. And as you might have noticed, it is basically the method signature or function signature, right? Just no body. And that's okay, we haven't filled the body in, we can fill it in down here. So that way, we can kind of avoid that weird parser behavior where it says, I don't know what you're talking about yet because I haven't seen that. Default parameters. Let's say I want to assume a certain value if 1 is not passed. We'll give it a default value. All right, so what should happen here? It should say, okay, I'm going to read from left to right. I have a parameter here. I'll associate with this first parameter. I don't have a parameter here, but since I have a default value, I'll substitute 2. And so I'll add this number to 2. That's what should happen. Too few arguments. Line 30, add nums. A. Oh, you know what? Did I do? Yeah, sorry. Silliness. Yeah, it happens when you switch languages. So sorry, that actually goes in the declaration. I knew that, forgot it. Whatever, it was purged along with my location of my car keys. I can't find now. I don't know. So anyways, you put it here in the in the declaration. So now when I call add nums and I don't have an argument over there on the right, it'll substitute 2. Give me 2 numbers and I'll add them. So we're up here, right? And I'll say 1 and 2. 1 and 2 is 3. Now, yeah, and I still don't have a space. If you guys would be better programmers than me, I'm sure. So give me a number and I'll add it to 2. All right, so I'll throw it 8 and it should give me back 10. Yeah, since it uses that default parameter on the right. Now, as you can imagine, there could be some ambiguity, right? Because let's do this. Let's say, give me 3 numbers and I'll add them. So we'll say first, second, third. So we got some defaults there. But it becomes a problem down here. Give me a number and I'll add it to 2. All right. Here's kind of the head scratcher. If I pass it A, let's say I only have, what is the parameter that, well, here, let's do this. There we go. So this is kind of becomes the head scratcher. Oh wait, hold on. Error C was not declared in the scope. Shooty doody. There we go. Yep. So you see, we still have a problem here. I'm passing A, but what's happening here? Well, the compiler doesn't like the ambiguity. It wants to know exactly what number you meant. So if you have default parameters, you had better put them on the rightmost side. Your non-defaults all have to go on the left, and that way the compiler will know exactly what you mean when you call the function, with the parameters passed, or with the values passed into the parameters. So from left to right, excuse me, your parameters with default values have to be on the right. Now this, oh boy, where are we? Let me go up some. No, that's not it. Add nums ABC. What is it griping about? Loader returned 1 exit status. Undefined reference to add nums. Oh. There we go. Yep. And so now it'll compile and it'll run. 1, 2, 3 is 6. Give me a number and I'll add it to. Oh, that's why that happened. There we go. So let's recompile this. Sorry. Kind of missing the trees for the forest, if you will. All right, 1, 2, and 3 is 6. And then, give me a number, I'll add it to 2, 8, will give me 10. Oh, look at that. What happened here? Oh, aha. Yeah, 8, 9, 10, 11, because I forgot I had 3 parameters and the values are 1 and 2. So 8 plus 3 is 11, and so this makes sense here. So this is kind of some basics about functions. These are enough building blocks for you to be really, really dangerous. Build, big complex problems. Anything at all, just, can reach out to me. And I guess if nothing else, I'll see you at the next lecture. Thanks.